As we discussed in the last session, we ended with the loop. So now we are starting with the loop again. First, we'll see how we can loop through the list. I mean, I wanted to compare with the dictionary. Okay. Hi, Inba, welcome. Yeah. So how we generally loop through the list? I just wanted to show you this value, whatever it is stored in this list. Oh, sorry. I mean, so, yeah. So now this list has 0 to 9. Okay. So I wanted you to, I mean, I wanted to loop through each element of this list. What we do generally in Python. So I mean, for each value in the list, I just val in list A. Okay. If we give the list name, it will directly walk through each of the values in this, right? That is what. So now I'm going to have this print of val. Okay. I type this. So we are getting all the values inside the list. Okay. Now for dictionary, looping through dictionary. Okay. So let me define a dictionary called D. Okay. So this is the syntax, as you know, and dictionary syntax is something like we'll be having key and value, right? Key and respective value. Okay, basically it's a key value pair. So here I'm just wanted to give key as, so for example, I'm going to give a number one and respective uh, text representation of it. Okay, one is one like this. Two is going to use two like this. Three. Okay. So as you see the values of this list, these are the list values. Okay, one, two, three. Okay. How you access the elements of the list? You use the dictionary name, which via dictionary variable name, and we have to pass the key. Okay. When you're passing the key, so here 1, 2, 3 is the key. Okay. If I give 2, execute this statement, we are going to get the value of 2. Okay. Similarly, if we give 1, 2, so the here this 2, 1, and 3 is not to be confused with index. This is actually key. So for example, I can have this way also. In place of 2, I can have this text here and the other way around. For example, I can show you that as well if you want. Let me show you for the 4, right? So this way I can see. Okay. Here the 4 is the key and value is 4. Okay. Now if I execute this statement, key for the first is 1, 2, 3, and the last value is 4. But the key is changed, not the number. It is the text. So to access the fourth element, if you do like this, it's a key error because that key is not exist. So what is the key here is 4, right? So 4 is the key. So it is not like the data type can be fixed for keys. Okay, it's as if I mean, it is similar to the list. So when you're going for the list, we'll be having various types of data we can put it in the same list. So it's a kind of heterogeneous list. Most of the languages, what we do, they come up with the list types they'll give, and they're not allowing you to store multiple different types. Okay, there is a way to work around, but that is different scenarios. But here, Python by itself, the standard library itself, it supports various types of elements to store in the list as well as in the dictionary. Here the keys can be the primitive data types like int, it can be a floating point number, it can be text. Similar to that, it can be an object also. That is also possible. But here that is not actually going to be useful here. So I'm just for the explanation purpose, it will be simpler to understand. Okay. And as I showed you, for the first three, the keys are integers. And if you see the last one is text, okay, we can do that is string actually. Yeah. So now we wanted to go through this list individually. Suppose if I write the same way, for example, the values I wanted to see in the dictionary D. So if I write this for loop and I wanted to print the values of this, so what is the expected result here? Okay. So in case of list, whatever values we get, print this. Okay. The values inside the list is 0 to 9. But here the values are actually 1, 2, 3 and number 4. Okay. But what we got is 1, 2, 3 and 4. So these are nothing but keys, right? So in order to get the values, so how we can get it? So the same thing we can do by accessing this way. For example, you can pass this like this. We can do. We'll be able to get it. This is also one thing. What if you want key and value both? Okay, that is also possible with this, right? This also we can do it. Okay, so this is how we traverse through the loop, and there is one more method. Okay, wherein they have an in-house, I mean, built-in methods, dictionary supports. I'll tell you what are those. Okay, you want to know what are the keys present inside the list. Okay, you can have a function called deck.keys. Okay, I mean the variable name dot keys. If you type, you will get out of the keys it's stored. Similar to that, we have d dot, I mean variable, okay, d dot values. So which gives you only these things. And there is one more option which gives both key value pair in a different format, which is nothing but d dot items. Okay, 1, 2, 3, 4. Okay, so this is how these are the various ways we can access the elements of the list. Only if you wanted keys, you can go for this. If you wanted values, you can take up this. And this d dot items is nothing but whatever we are key value pair we are getting, you are getting in a tuple format. Okay. So generally people when we're going for dictionary accessing, right, they don't want to derefer using the dict every time. Okay, so as we used this way, d of val, key and val. So what they do at one shot, they'll be getting this key and value without dereferencing using this uh, key operation. Okay, so to overcome that, what they do, they use this d dot items. So how they use this, let me show you. Okay, if suppose for loop I have written, so key and value in d dot items. If we do this way, print k comma v. Okay, you are going to get the same values. So as you observe here, whatever values we get in 1, 1. So for the first time, whatever we get is 1, 1. So this is kind of assigned to this key and value, and it is getting printed. Okay. So these are the various ways the keys can be, I mean, we can loop through the dictionary. Okay. So here, I mean, I just wanted to go for, so in the last week's class, we have seen how the dict can be, I mean, how the variables are declared, how the data types are assigned. There are few things, the core details we have missed. Okay. So I wanted to get to there, and let me explain what happens at this particular step. Okay. For example, during the first iteration, what it happens is we are trying to assign this to this k comma v. Okay, that is what it happens. So there is some concepts. I will explain that. Okay, running behind. Whenever we do a variable, for example, a is equal to 2, so it is assigning these values to this, right? So that is what it happens. So now Python supports multiple assignments. So wherein we wanted to declare multiple variables with the same value, what we can do like this. Okay. In this case, if we print a and b, I'll just put a print of a and b and then print the values of a and b, we're going to get the same value. So which is actually, it's kind of multiple assignments they say. Similarly, what they can do, we can define the values like this. Okay. Suppose I wanted to initialize with different values. Let's see how this works. Okay. So this is like we are doing assignments, the respective values it will go through. It will get assigned. So here actually speaking, suppose instead of this, I'm going to replace this with an equal. What is the value it will get stored? 2 comma 3, 2 comma 3. Okay. In the hands-on session, we might have seen there is a function called a type, right? I guess you might be able to recall. So if not, it's not an issue. Just follow me, you can get it. So now value of 2. So the previous, there are three cases. So one is like if I use this way, A is equal to B is equal to 2. This A and B stores the 2. Okay. And second case is A comma B equal to 2 comma 3. So here the results are A is equal to 2 and B is equal to 3. In place of this comma, if you replace with A equal to B equal to and 2 comma 3, the values are coming like this. Okay. So now there is a difference. So what is happening behind when you're giving these values? It is actually treating this as a tuple. Okay. So that is what we are going to check. So now we have the values A, comma A and B. We try to see the values of this. 2 comma 3, 2 comma 3. Okay. So now I wanted to check the type of A. What is the value it's stored? What is the type? So type is the keyword. To know what is the type it is representing. Okay. So it is pointing to tuple. So that tuple is nothing but 2 comma 3. So this is somewhat relevant to this concept 1 comma 1 which has been assigned to this k. So this particular k comma v is equivalent to k comma v. This is something I will just give you this example with respect to this dictionary iteration. To take this. Okay. For example, I'm just going to give an k. Sorry. Yeah. I'll just for the first value, whatever you are going to get through this items, right? When you use items, so what is the value you're going to get this way? And the very first value is pointing to 1 comma 1, which is actually a tuple, and we are going to assign this. The same thing we are just what to say expanded, and we just want to understand what is happening internally. So this is what it happens. Okay, every line it goes through each and every value of that tuple and will get assigned. So with this, what is the result of this? Okay, if suppose I'm executing this statement, what is the value will get stored in k? What is the value it's stored in v? Okay, so do you guys want to answer this? We can answer. Can you yeah, can you tell me the answer for this in the chat session? Okay, I think we have already did this. Maybe it's a direct question. So, okay, I assume you guys understood this concept. The values are nothing but one, and this value will be one, and key will be stored as one. So you can confirm this by using printing these values a comma v. Okay, the key is this, values this. This is what internally happens when you use items. Okay. So when you use this particular way, it is kind of assigning these values and then taking these values and assigning into this. This process is called as unpacking. Okay. So what it does is it is taking tuple is a kind of a pack, single pack. Okay. So this particular pack of values, when you are trying to assign into multiple values, it is trying to unpack these values and get it assigned. So it is actually speaking, it's a single unit. When you say it's a list or a tuple, it's a single unit of this. Okay. When you're trying to assign to these values, it gets split and assigned. Okay. This is one behavior. When I'm not sure when what happens when you replace this with list instead of tuple. If suppose we are going for list, whether this works or not, let's see. Okay. So what I have done, I have assigned this particular thing. So let's see what is the thing happens internally. Okay. So here also it happens. So what it does internally, the Python, it does this unpacking and assigns these relevant values accordingly. Okay. This is what happens. So when this particular feature will be useful when you are passing or calling a function with tuple. If you are passing it, it will, if you are assigning a tuple coming from somewhere and get it assigned to this internally, the values will get unpacked and get assigned for each of the arguments. Okay. And okay, yeah, This is what it happens internally. This will be useful. You will understand if you started using this kind of things in the real life. You will understand why the what is unpacking, what is packing. Okay. So here mainly the unpacking is something like what happens is we are trying to uh, split the pack of values into individual elements and get it assigned. So here we can ask, what if if I declare, suppose I just remove this, let's go with this above concept only. What if I'm having one more, for example, say for x, okay? This one more value, I'm just planning to take it out, but it doesn't have this, okay? Okay. So we are getting an error, value error, because it does not able to extract this, unpack this thing to get it assigned. And it clearly says, the error says, not enough values to unpack. Got it right? So here the expected value is what it is trying to assign to three variables. It needs values, unpacked values get it assigned. But if you see it has only two, so which cannot be assigned for these three. That is why we are getting an error, which is nothing but an value error. So that is why we are getting this. Okay. Not enough values to unpack. Okay. The same way, what if I showed you one more example in the top. I'm just want to I will just type it again here. Okay. The thing is, if k is equal to and b is equal to, and then just giving this 2 comma 3. If you see, these two values are individual values. Okay, when you put comma here, it get assigned 2 and 3 to the k and b. So if you do this way, the value of k, if you wanted to see only the value of k, is 2 comma 3. So here what is happening? It's happening in the reverse way. Okay, so here what happens is, instead of unpacking, it packs these two values into a single thing. And here also it gets assigned. Even value of k and v both are having the same tuples. Okay. K is also having this and v is also having this. Okay. So this particular process is called packing. So I hope now you understand what is packing and what is unpacking. And based on this packing, unpacking only, we are able to browse through the dictionary for the key value pairs. Okay, and which is nothing but the d dot items and d dot key and keys and values, whatever we saw. So these are the kinds of internal functions provided by the Python itself. Yeah. So in order to understand what is happening under the hood, I have given you the explanation. Okay. So far, you guys able to follow? Please confirm in the chat so that I can move on to the next session. Are you able to follow? Okay. If yes, just type yes in the chat, or else you wanted to explain this concept again, I can explain. Okay. Thanks, Mahesh, for confirming. Yes. And what about Saujanya and Inba? You guys able to follow this? Okay, guys, please be interactive so that we can get to that. I will know whether you guys understood or not. Okay. So if you want to repeat me, you can feel free to ask me. I will repeat it. Okay. Okay. I'm just assuming it is an S. If you have any questions, you just stop me whenever you want. Okay. So now we have understood the loops on dictionaries, and we have understood the concept of pack and unpack. Okay. There is few more things which I guess most of the people who works in Python also they don't use this kind of concepts. Since I wanted to tell that, I'm just going to give an introduction about that. Okay. Okay, so each for loop and while loop, there is one more new construction. Whenever you see in any other languages, we'll not have the if only will have follow up. If only will have the else option. But Python provides an option like for loop, and we have this our statements. Then we will have our there is an option for else. When do we use this? That is the question. Okay. So this particular provision is provided by the Python. Okay. So this is somewhat the syntax it looks like. I'll just replace with some actual values. Okay. For also supports else and while also support else. I don't know whether this will be confusing or not. I'm not sure whether. Okay, if you want, I will introduce this topic for later part. If you want, I can go through or else.
Give an example, they will understand.
Uh, okay. So generally, whenever we do right, we have introduced something called break and continue keyword. So do you guys able to recall that? So break is something like whenever you wanted to write something. So we will be okay. For example, I'll just make this list A only. We have already a list A which is defined above. Okay, it's been replaced. Okay, that's okay. I'll create a new list. For example, I'll be creating from the range 0 to 10 or 20 with step value of 2. Okay. But before executing this, I just want you guys to answer me what is the value of this? Okay. So what will be the values for range of 0 22? And I'm just converting to list. I'm not sure whether I can. Okay, I will just go through this. I will not. So this particular statement which I gave is like we are going to have these values. Maybe I have created a list at an interval of 2. Okay, so 0 2 4 6 16 to 18. So it create a value of interval with interval of 2, and that's how we initialize this list. Okay, so we are going to run through this list. Okay, for loop. We are writing a for loop. So what we do generally for val in a, we just wanted to print the value. We do print. Okay, and instead of printing, I just wanted to check a condition. If suppose in this list, if I have the value 13, just break the loop. If not, we can continue the loop. Okay. So for example, if suppose I wanted to check the condition if value is equal to 13, then break the loop. So break is like breaking the loop. It will not continue the loop. I guess you guys understood that concept. Continue something. It will continue the loop, but from where it sees the continue, it will go back to the for loop and it will come back to the same loop. Break is it will break this line. It will move to the new line. Okay. So here what I'm going to do, whenever it sees the value 13, it is going to break. Otherwise, it is continuing and it's going to print the value. Okay. As per this, the expected results is we don't have the value 13 here. Okay. Okay. So 0 to 18 it printed. So now assume that I'm inserting a value 13, for example, at the index position of 8. Okay. What is the value I'm going to insert? 13. Okay. You can see the value of A as well. And I'm trying to print 13. Actually, we are having 13 here. Okay. And this loop continued till 0 to 14. Since it sees the 13, it break and it didn't execute this statement. It come out of that loop. Okay. So whenever this break condition executes, uh, we don't want it to do some operation. But if suppose, just give me a minute. So this is the plain logic how we use break and how we use this loop. So before that, I will. So there is a concept which I explained you. So Power also supports else. I'm just trying to print this else. Okay. So else. So when this block will get executed, we will try to understand. Okay. Or else. executed. When we will be using this, we'll see. Okay. The same statement I'm going to execute with 13. This else block never get executed. So which means whenever the list is not fully consumed, this else block will never get executed. That is the understanding here. For example, if I suppose I remove the value 13 from here, now the list become, there is no 13 in this. Okay. In this case, if you see 0 to 18, it executed and else block also executed. So this particular else block here in this for loop, what it ensures is whenever you are trying to go through this particular loop till the end of the list you traversed, and you have some kind of conditions. If suppose so here in the case is very it doesn't see any useful concept here. For example, you are trying to find an element which is present here. Okay. So here the finding element is 13. Okay. It's the key element which you are trying to find. So if the element is found in this 13, we are going to break the statement saying 13 found in this list. Okay. I'm just going to change this logic saying 13 element 13 is found. If it is not found, what we need to do, we have to have a condition. If the value is not found, we have to write a logic. We have traversed through the list and we couldn't find it. So if you assume there is no else statement, how you do that? Okay, this is with else. Before without else, I'm just trying to. In this case, say for example, we are not giving any print also. Okay, in this case, whenever the element is found, we can say L is 13, then we say break. Otherwise, we are going to continue, right? So what we do here, else part, we continue. Otherwise, we can print here element not found, but it will coming for every time. Suppose in this case, element is not found. If you do, it's the wrong way to do, right? I'll say what happens if I do element found here. What happens is, so it prints for every time the loop it is going through. So for example, here 0 to 18, for each index position, it is trying to go through and compare the values. Element is not found, element is not found. This is not the expected behavior for us. I'm giving you a list. You just tell me element is found or not. Okay. So to do this, so what we can do is we cannot print here. Okay. Instead, what we do, we need to continue. Okay. Once you do continue, it will keep on continuing and it will keep checking if the value is not printed. If this value is not printed, we need to know it never entered into this. Okay. So what we do in general in any programming language, we will introduce some new flag value, whether it is entered here or not. For example, element found. I'm just going to create this Boolean type, bool type, which I showed you in the last first class, the data type called bool. So I'm just going to create that. Suppose, okay, found is the flag value I'm just going to define. I'm just initially set it as false because we are trying to find whether it is present. If found, if it is entering into this equal to 13, then what we do, if the element is found, so the found flag will set it to true. Okay. So how you can programmatically check is if this flag is looped through this particular list and if the value is found, we are setting this value to true. Otherwise, it is false. So how we can check this condition? If found is equal to false. Okay. This way we don't need to check because of bold type. We can check it in the other way around. I'm just giving for a better example. Okay. So if found is equal to true means it will print here. If in case of false only, it is going to come here. Okay. This condition will get passed. So here, what we can say, element 13 is not found. This is the logic. You guys are able to follow this logic, right? So what we did, we created a flag for called found, and that found flag we are setting true here, and whenever the element is found, and then we are breaking this. Once it comes here, if it is already true, it will not execute the statement. If suppose it never entered this, it will execute this particular if condition will become true, and it will print. This is the expectation, right? Now, as per this new list, we are not inserting any element 13. So the element is not there. The expected result is element not found. Not for this multiple times, only one time it should print. Okay. It is clear that element is not found. Okay. So in this scenario, for checking this particular logic, we have made a statement of this, and we have introduced this. Okay. All these statements can be replaced with a simple else. That is what the idea of for else. Okay. This is where the Python for else structure helps. Okay. I'm just going to comment this line. I don't want this line. I don't want this line. Instead, what I do, if the complete list is consumed and I'm not able to find, so what I should do at the end. Okay. That is where we are trying to do. So here we don't have this all this found and everything. Just adding these two lines will help you to understand. I mean, will help you to validate the element is not found. Okay. So let's try. Okay. Instead of introducing new flag and checking condition, all these things is replaced by a simple else is the for loop. Okay. This particular kind of for else logic I never seen in any other language. I personally I used Python. I mean I used Java, C, C++. I never encountered such things. Maybe it is there in the later things, but I never seen. So this is kind of something unique with Python. I observed. The thing is, I was little wondered why this else is what is how it makes sense. If else makes always sense. For else, what is that? So then I was curious and what is it I was trying to explore. Then I got to know this is the way we can make use of it. Okay. So it made a long code very simplified. Okay. So assume here in this case also you can trying to write all these kinds. And if you miss some values here and it will be error prone. So all these logics are handled by this simple else. It's very good. So it comes very handy if you understand these concepts. Okay. So are you guys able to follow this concept? If you have any queries, if you need one more explanation, I am ready to explain. If you have any confusion here, please interact in the chat so that if you have any confusion or anything, I can go for one more time. Otherwise, I will move on to the next topic. Okay. So whenever you guys are silent, I'm assuming it is yes. So please ask questions. These concepts generally they don't explain most of the cases. So we are explaining just because we have experience in this, and I wanted this session to be very useful for you guys. Okay, it's not like just the basics. We wanted to give some advanced topics as well. The very first week, whatever we covered is kind of a basic Python, and what we are today we are looking is little advanced level. Okay. Okay. So you wanted to explain Boolean. Good. So Boolean is kind of so we already saw the data types, right? Data types which is like int, string, and there is one more concept called bool. Okay. So here Boolean variable is nothing but to store true or false, right? So as you know, Python doesn't need to define the data type. So suppose I'm just checking a flag value. It's nothing. Its flag is nothing. Something a name. Okay, which I'm giving, and I'm going to give assign a value called true. Okay. So this boolean is nothing but it's a kind of in a digital gates how you say 0 and 1. So to check that particular it maintains only two states. It's like it's instead of storing multiple numbers, it just holds a value 0 or 1, which means a bit set or bit unset like that. So in this case, boolean will helps you to set a flag whether this is entered here or not. So here we are trying to leverage this particular bull type, whether this is enabled or not. Whenever there is a need for only two states, okay. Suppose we are encountering on or off, exist or not exist. So these kind of conditions we wanted to check and wanted to store that conditions in a variable, that check in a variable, we go for bool. So when generally this integer types or string types, whenever you wanted to store a number or a text, we go for that particular integer type or string type. But here we wanted to store the state of the, we wanted to capture that particular state on or off. Okay. So to store that particular, if suppose I'm saying I wanted to define a logic, for example, in a house, if the switch is on, okay, the switch is on or off, what we can do, these are the two states, right? So we don't need to define a string or something. So instead, I'm just given for what is the state we are going to have. So for the switch is on, we can have it as true. Switch is equal to true means it is on. Okay. Switch is false means off. So what we can do, if the switch is on, as I told you, I don't need to check this condition like this, equal to true and all these things. We can directly use if switch. So this is nothing but when you are executing a statement, conditional statement, what we are getting is a boolean. So here already we have a boolean. We don't need to expand a condition like this. So if the switch is true, I'm just going to give this statement. If it is true, then I'm just saying turn on light. Okay. Else, so here, in this case of Boolean, we don't need to worry about using elif. Okay. Why? Because it has only one other state. Okay. There is only two states, either true or false. So here you are adding elif condition. It's kind of an overhead. It doesn't need. Okay. So why I'm just sticking with the else itself. Okay. So now what I'm saying, turn on light is if the switch is on, or else if it is off, the state is changed to that turn off light. Okay. So here the logic is we are making use of this bool variable which stores two states either on or off. So based on that we wanted to write our logic. Whenever there is a requirement in your programming to deal with only this kind of two scenarios, on off, exist not exist, something like that. Okay. So in those cases, this bool variable will come in handy. And if you see the programming logic also, it is very simple, right? You can see the condition check we are not doing is switch is equal to true. I made it here for the understanding purpose. We don't need to write it this way. Okay. We can directly, if the condition like how we use the condition, in place of that, we can directly use the bool variable. That's the thing. I hope Boolean is clear now. So with respect to Boolean, I have created this particular approach, right? Uh, just- so here what I did, I wanted to use this Boolean. Okay. So to use that Boolean, because here the condition is to check that the element is found or not found. These are nothing but two states. To capture these two states, I just declared a variable called found, which is a Boolean type. And when it is found, why I am setting it initially false, before checking the actual element in the list, it's better we have to define that is not found, because until unless we find, we'll say it is not found state. Okay. To store that not found state, I'm declaring the initialization value as false. Once it is found, I wanted to change this value to true. That is what I did here. So once it changes to true, I wanted to check. Okay. Finally, after coming out of this loop, I wanted to check the value whether it is found or not. So that is where this comes. Okay. So I don't need to check this condition. What instead I can do, if found means it's true. Okay. So I don't, but that element is found, but I wanted to print only not found. So what I can have is I can use the not operator. Whatever results of this, we are trying to negate it. It's kind of a complement or it's kind of uh, opposite of it. Okay. So if here the found is false because A13 is not here. So we're trying to convert this 13 to, I mean, whenever it is found, we are making this condition false. If it is not found, we want to make it true. Okay. So that is why we are using this condition. Let's try to execute this. Okay. Element 13 is not found. Whenever you insert this element, that's it. I hope you understood this now. Is it clear, Mahesh? Yeah. I'm just using for else. Okay. Here there is one more way to optimize this code. So where you see there is a kind of uh, just give me a minute. Yeah. Some code we can avoid here. We can improvise. Okay. Some code we can improvise. So what happens if I don't give this particular else continue? What is the what will happen to this code? So as you know, it starts with this particular condition. I will just have this values as well. Copying here. Yeah. So the value, whatever it has is 0 to 18 and 13 is also inserted at the index position 13. Okay. So we are going through each and every element of this list and then we are trying to find whenever it is found, it is going to break. So if it is not found, by default, the behavior is it will continue the loop. Okay. We don't need to have this condition else continue. Okay. That is kind of unnecessary thing. That is for our understanding purpose. But internally, implicitly, what this does here is whenever you see this for loop, so it is going through each element of this list until unless you have some kind of breaking logic inside. So here the break logic will get executed only when it is found. Otherwise it will not execute. So we can write this way. So let's see. This is like more compressed code. This is the way we optimize. So there will be some unnecessary. So logically, if you think all these things will make sense, but implicitly Python provides some features. We will leverage that and we will make efficient programming. Okay, this is how we do. So whenever you write a program, okay, so here element 13 is found, so we do this. So this condition it worked. If I want to check the other way whether it is working or not, element is not found, both condition it worked. So which means the list is continuing until unless the element is found, it is continuing. When it is found, it is breaking. It is not found, it is coming out to the else. Okay, this is the way of optimizing the code. Even anyone who try to write the code, don't try to optimize at the beginning itself. This is out of my experience. When you try to do that optimization, you will spend more time wasting in that. Out of experience, you can do it. But sometimes what we do, we try to write in the way which we understood and try to remove the unnecessary elements. That way, you can understand. You will be clear in the flow. Whenever you try to use the shortened operations or any such things, you will end up in a problem. So wherein you will be getting a weird result which is not as expected. So don't do the optimization at first place. Try to write and execute in the first iteration, try to execute the logic, whatever you have in mind. And the next iteration, what you have to do is try to optimize. What are the things are redundant here, what we can drop, what we can do this way. So that way we can be safe. So if you drop this, it will not change the result. That way we can verify it. Okay. That is the better approach. Now we saw for loop. The same way, even the while loop is also working. So for a, I think, let's see. Okay, this while else, I'm just going to give us an homework for tomorrow. So before coming to tomorrow's session, you guys can take any example of yours, traversing list or while loop. I have given. I have given you explained you how while loop works. Even the hands-on session also while loop, how to use he explained. So I want you guys to be interactive. So at least not here in the home, you can try writing a while loop and use an else logic there and come back. Okay. Tomorrow we'll see how many of you guys are able to do. If you're not able to do, we'll discuss here. Okay. That's it. Yep. Okay. So still till now. Just give me a minute. So until this, you have any questions or any queries? So far the sessions, whatever we covered, you can ask. Or else, we'll take a short break. Okay, we'll come back after that. If you have any questions, you just let me know. Just give around 5-10 minutes break. We'll be back around after that. Maybe we'll not have a 3 hour session today, so we'll cut short that. Or else, if you want me to continue, I can continue. Or else, we'll take a short break and we can continue for the next another 1 hour. Then we'll wind up the session of this week today. Okay, let's take it's been 1 hour now. Let's take a 10 minutes break and come back, and then we'll continue the session for another 1 hour, and we'll wind up with that. Okay. So I'm just going to stop this recording for time being. We'll restart that after this.